Good afternoon. I, Bhavna Faculty, School of Finance and Commerce, Galgottias University, is going to give a presentation on the topic Formulation of Linear Programming. What is linear programming? Linear programming is that method to achieve the best outcome, such as to maximize the profit or to lower the cost. In a mathematical model whose requirements are represented by the linear equation. Let us learn more about the linear programming in this video. I hope that this video will be very useful for you in formulating our real life problem into the mathematical model, and it involves the various types of variables and objective functions.
The following are the prerequisites. The first are variables. In linear programming, we are having the different types of variables, and decision variables are one of them. These decision variables are the economic and physical quantities whose numerical value indicates the solution of linear programming problem. These variables are under the control of the decision maker and they could have an impact on the solution to the problems under the consideration. The next are the constraints. There are the linear equations which are arising out of the practical limitations. So, we should know what are the linear constraints. Along with that, we are having the linear functions. As we know that linear functions, it contains the items each of which composed of only the single and the continuous variables, right? And these prerequisites are very useful in understanding the concept of the linear programming. The objective of this lecture is to make you understand about how to formulate the linear programming problem. In linear programming models, there are the functions which are called as the objective functions, which is to maximize and to minimize while satisfying the several conditions and constraints. If there are only two variables, the one can use the graphical method of the solution. So let us begin with a set of constraints and consider them as the system of inequalities. The solution of this system of inequalities is a set of the points, and the objective function need to be evaluated for the different feasible solutions and maximize and minimize value can be obtained. So, the linear graph, it consists of the different types of nodes or points which are joined by some or which are joined by each other. So following are the steps for solving the linear programming through the graphical method. The first step is to formulate the linear programming problem. In this, the formulation requires to translating to the real life problem into the format of mathematical equation that represents the objective functions and constraint set. Often, data gathering, problem definition, problem formulation are very important. These steps are very useful for any of the operational research technique. Although the understanding about the problem is necessary, but formulating them correctly is more important. During the formulation stage, an OR specialist may discover the new sides into the problem that might change the scope of the original problem. For this reason, it's very important to obtain the help of those who works very closely with the system being studied. This can be helpful while understanding the problem, and it helps the OR specialist to collect the necessary data and to define the problem so that a valid model can be created. The next step is to construct the graph and to plot the constraint line. Constraint lines, they represent the limitations on the available resources. Usually, the constraints line are drawn by connecting the horizontal and vertical intercepts, which are found in each constraint equation. The next is determine the valid side of each constraint line. The simple way to start is to plug the coordinates of the origin and see whether the point satisfies the constraints or not. If it does not, then all the points on the original side of the line are feasible and all the points on the other side of the line are infeasible. And we have to see that all the points are required to be satisfying the condition of the feasible area. After that, we have to identify the feasible solution region. The feasible solution region, it represents the area on the graph that is valid for all the constraints, and choosing any point in this area will result in the valid solution. The next point is to plot between the objective function line to determine the direction of the improvement. Improvement in the direction of the greater value when the objective is to maximize the objective function, and in the direction of lesser value when the objective is to minimize the objective function. The objective function line does not have to include any of the feasible region to determine the desirable direction to move. The next is to find out the attractive corners. The optimal solution always occurs at the corners, and the most attractive corner is the last point in the feasible region, which is touched by that line that is parallel to the two objective functions. So, these are the steps which are required to be followed for formulating the linear programming. The last step is to determine the optimal solution by algebraically calculating the coordinates of the most attractive corners. And the next is to determine the value of the objective function for the optimal solution. Now let us find out the feasible solution for the problem of a decorative item dealer whose linear function is to maximize the profit function. So, maximize z is equals to 5x 50x plus 18y subject to the constraints, that is 2x plus y. Then we are having less than equals to 100, x plus y less than equals to 100, and then we are having the non-negative constraints. So let us learn that how to solve this problem. So since x is greater than equals to 0, y is greater than equals to 0, so we considered only the first quadrant. So let us draw the straight line for the equation. In the first equation, we are having 2x plus y. Let us make it equivalent to 100. Once we put y equals to 0 in equation 1, and hence we get the value of x equals to 50. In the same equation, let us put x equals to 0 where we get the value of y equals to 100. So, these are the points which we get, and now we will be plotting these points on the graphical line and draw the line which represent this complete line. Now let us plot these points on the graph. We will be taking the two lines x and y for plotting the various points that we have taken from the equation. Like in first equation, when we put the value of y equals to 0, we get the value of x equals to 100. So let us plot this point on this line. The next is when we put x equals to 0, then we are having the value of y equals to 100. So let us plot this point on this line. After plotting the 2 points, let us join these lines by joining these 2 points. The next is equation second. In second equation, we were having x plus y equals to 100. So first we put the value of x equals to 0 and we allocate on y, which is 80. Then we used to put the value of y equals to 0 and we allocate the point of x equals to 80. So let us join these 2 points to form a complete line, and then we will be joining these points together. Now as we can see that in this question, less than equals to area, less than equals to sign has been used. So we are going to have the common area of these two lines. So let us take the common area in first and in second equation. As you can see that this is the common area that we find in by joining these two lines. We get the point A, B, O, C. So these are the 4 points of the feasible area. That will be in A we are having 0 and 80, in B we are having 20 and 60, in C we are having 50 and 0. So we are going to put the values of these points in the objective function. The objective function was maximize z, that was 50x plus 18y. So I am going to put these points one by one in this objective function. Let us take the first point, which is O, that is 0 and 0. The second point is 0 and 80. So when I put this value of 0 and 80, that is x equals to 0 and y equals to 80 in the objective function, I get this value of 1140. The next is at point B we were having 20 and 60. So let us put these two values in the objective function. When x was 20 and y was 60, we get the total amount of 2080. The next is we are having point C, which is 50 and 0. So let us put the value of x, which was 50, and y, which was 0, in the third equation. So we get the value of 2500. Now in this question we want to minimize the problem and we want to maximize the profit and minimize the cost. So maximizing the profit will be at that point where we are having the value of x equals to 50 and value of y equals to 100. Then the optimum value that we are receiving in this question, it will be 2500. So we can say that the optimal solution is x equals to 50 and y equals to 0 and the optimal value is 2500. I hope that this video will be very useful for understanding the concept of the linear programming in a better way.